Assalamualaikum and hi. This is for the convolution assignment video for group 8. The group members are Law Fuhui, Dian Wani, Abi Shahni bin Nur Hazmi, and Nur Amira bin TGD. The objective of this assignment is to calculate the convolution operation, to describe the response of an LTI response and the use of MATLAB, to plot the result of this operation. In this assignment, student will analytically evaluate and verify result using the MATLAB. For the methodology, the first one is the addition of the signal zt equal to x1t plus x2t. Number two is convolution of signal yt equal to x1t multiply x2t. Task 1, number 1 is regenerate the signal. From the graph given, we will find the mathematical expression for GT and HT. This is the value we get. The task 2, the question 2, task 1, I'm sorry, the addition of the signal. From the given equation, we will identify the component value and the range of t, and then we will calculate the amplitude of each signal for each duration of t, and we total it. This is the signal zt from the addition of the two signal from the previous slide.
Next, I will be explaining the task 1 question 3, which is a convolution. A convolution is an integral that expresses the amount of overlap of one function when it is shifted over another function. In this question, a signal ht is multiplied with another signal gt to produce an output signal yt. This is the equation of the convolution operation. The first step is to change the independent variable used to move through the ht signal and the gt signal. That is, we replace t with tau to make ht and gt become h tau and g tau respectively. The next step is to flip the signal g tau, turning it into g minus tau. Shifting the flip signal g minus tau to the location t results in the expression becoming gt minus tau. The ht is then multiplied with gt minus tau to get the output signal of yt. This is the combination of the signal ht and gt minus tau. Then, the value of the output signal is then found by integrating the multiplication of two signals from negative to positive infinity as shown in the slide. This equation is called the convolution integral. For the first case, when t is smaller than -2, the figure shows that the two signals do not overlap at all. This means that the product of the two signals is 0 at all locations all along the tau axis, and the resulting output signal is 0. A second case is illustrated where t is between -2 and -1. Here, the two signals partially overlap, resulting in the product having non-zero values between tau equals to -1 and tau equals to t plus 1. Since this is the only non-zero region, it is the only section where the integral needs to be evaluated, and the output signal is given by the expression as shown. The next figure shows the calculation for the third section of the output signal, where t is between -1 and 0. Here, the overlap occurs between tau equals to -1 and tau equals to 0, making the calculation the same as for the second section, except a change to the limits of integration. The output signal is shown in the slide as well. The fourth case is illustrated where t is between 0 and 1. The signal gt minus tau overlaps with two different amplitudes of the signal h tau. Therefore, for the amplitude of 2, the overlap will occur between tau equals to t minus 1 and tau equals to 0. For the amplitude of 1, the overlap will occur between tau equals to 1 and tau equals to t plus 1. Separate integration is needed to solve this. The output signal is shown in the slide as well. Next, the fifth case is illustrated where t is between 1 and 2. The two signals partially overlap between tau equals to 1 and tau equals to 2. The calculation is the same as before, except the limits of integration is changed. Here is the output signal. This is the sixth case where t is between 2 and 3. The two signals partially overlap between tau equals to t minus 1 and tau equals to 2. The calculation is the same as before, except the limits of integration is changed. Here is the output signal shown in the slide. The last case is illustrated in the slide. The last case is the same as first case, as both signals do not overlap. Therefore, the output signal for the last case is 0. Here is a combination of all the output signals. The graph is presented by using the online graphic calculator. That's all for task 1 question 3.
Okay, now I will start to explain about the MATLAB coding for us to perform the signal GT and HT in the time domain. Firstly, we declare the increment of the t-axis, that is 0.01 second, and then the time domain is ranging from -4 to 4. And we declare our GT function, which is the triangular function, as the t plus 1 multiply t greater or equal than -1, and then t less than or equal 1. And HT is equal to the rectangular function, which is the 2 multiply t greater or equal than -1, and then t less than or equal 0, plus 1 multiply t greater or equal than 1, and then t less than or equal than 2. This represents the ht function in the right hand side. And then we will plot the gt function with the title label signal gt in the time domain, and then with the title ht graph in the time domain. Okay, now I will start to explain about the addition of two signal. So when we want to perform addition of two signal, we will directly use z equals to g plus h. So after we plotting the graph, we will obtain this signal z in the time domain, which represent at the figure 3, signal z equals to gt plus ht from MATLAB. Okay, so for part 3 in the task 1, we will require to perform the convolution between two signals. So firstly, we initialize some variable. The first one is a time 1 equals to 0, which we initialize the time equals to 0. And then t2 is the time range of the generated convolution graph, which is from -4 to 4 with the time interval 0.05. And then t tau is the time range of the convolution process graph, which represent at the right up the graph, which is from the -2 to 3 with the interval 0.01. And then we declare the convolution function as y equals to NaN, which represent not a number, multiply zeros in bracket 1, and then the length with t2. Okay, now we will continue to declare the gt and ht function. Gt is a triangular function we obtained from the task 1 part 2 for part 1, and the ht is the rectangular function from the previous question. So after that, we will start to do a for loop in order for the signal to move. So we declare the increment of the time as t1 equals to time 1 plus 1, and then we start declare the convolution function as z equals to g t minus t tau multiply h t tau. This is represent the convolution function for each time period. And then in order to obtain the final convolution function, we need to sum it up. So we write yt1 equals to sum z multiply 0.01. Now we will continue to plot the graph with the first graph is the convolution process graph, which we are used to perform the convolution between two signals. And then with the second graph is our output, our generated convolution graph, which represent at the right hand side.
Hello, my name is Nabil Shamid. I'll be presenting the process of calculation for task 2, which is convolution. A signal ft is fed into an LTI system, which is linear time invariant system, ht, and the output will be denoted as yt for our group. ft is 2 rem t u t minus u t minus 1. For the first thing we need to do is visualize the ft signal. Signal ft can be obtained by combining the signal 2 rem t and the signal ut minus 1 expression. Next, the signal ht can be obtained by combining the signal for 1.5 ut minus combining the signal for next the signal ht can be obtained by combining the signal for 1.5 ut minus 1.5 and the signal for ut minus 2 minus ut minus 2.5 expression. After that, t is replaced with tau for both signal and ht, and ft becoming h tau and f tau, and then the signal f tau is reflected into f minus tau and then shifted into ft minus tau as shown. So here is the combination of ft minus tau and h tau of this combination signal. To find the product signal yt, ft minus tau is shifted to the right to produce overlapping signal between h tau and ft minus tau, and then the convolution integral is solved. For case 1, t is smaller than 0. Yt will be 0 as there is no overlap between the two signal. And the next one, case 2, which is t smaller than 1 but bigger than 0. Signal f, t minus tau, is shifted to the right before 1, and the limit of the integral becomes t and 0. The value of yt calculated is 1.5 t squared. For the next one, which is case 3, t is smaller than 1.5 but bigger than 1. Signal f, t minus tau, is shifted to the right before 1.5, and the limit of the integral becomes t and t minus 1. The value of yt calculated is 1.5. For case 4, which is t smaller than 2 but bigger than 1.5, signal ft minus tau is shifted to the right before 2, and the limit of the integral become 1.5 and t minus 1. The value of yt calculated is negative 1.5 t squared plus 4.5 t minus 1.875. For the case 5, which is t smaller than 2.5 but bigger than 2, signal f t minus tau is shifted to the right before 2.5. Since there is a separate overlap, the integration limit of the first overlapping signal is 1.5 and t minus 1, and for the second one is t and 2. The product of yt calculated is minus 2.5 t squared plus 8.5 minus 5.875. For case 6, t smaller than 3 but bigger than 2.5, the signal f, t minus tau, is shifted to the right before 3, and the limit of the integral becomes 2.5 and 2. The value of yt calculated is negative t plus 2.25 x. In case 7, which is 3 smaller than 3.5 but bigger than 3, signal f, t minus tau, is shifted to the right before 3.5, and the limit of the integral becomes 2.5 and t minus 1. The value of yt calculated is t squared minus 5t plus 5.25. And for the last case, which is case 8, which is the t is bigger than 3.5, signal f, t minus tau, is shifted to the right beyond 3.5. Hence, there is no overlap between the two signal, and the yt signal will be 0. That's all for task 2 calculation. Thank you.
Okay, now I will start to explain about the MATLAB coding for the task 2. Firstly, in order to perform the convolution between two signals, we need to initialize some variable. The first one is that we initialize the time as time equals to 0, and then t2 is equals to the time range of the generated convolution graph, which is from negative 2 to 6 with the time interval 0.05, and then the t tau is equals to the time range of the convolution process, which is from negative 2 to 3 with the time interval 0.001. Okay, for the convolution function, we declare as y equals to NaN, which represent not a number, multiply zeros in the bracket 1 and the length of t2. So for the f function and the h function, f function is a triangular function provided, and the ht function is also represent the rectangular function provided in the question. So in order to perform the convolution of the ft and ht signal, we define the convolution function for each time period as the z. Z is equals to f in bracket t minus t tau and multiply h t tau. So in order to obtain the final convolution function, we need to sum it up. So we write as yt1 is equals to sum t multiply 0.001, and then we will obtain the graph by plotting it. Okay, so for the first one, the graph one is the convolution process graph, where we show our convolution process. And then the second graph is the generated convolution graph, which is the output of our convolution process.